Come on and cry me a river, cry me a river. I cried a river over you.
Good morning, everyone, and welcome back to this corner of the internet with new music. We have Snoopy music, jazz, beach jazz, relaxing big jazz, ocean breeze ambience. Let's see how it works with this. How are you doing? I'm doing fine, thanks. I hope you're doing fine and well too. Today, I have two articles to share with you. Let's read it. First one in line is: brain scans reveal how people with autistic traits connect differently to each other, I think, by Karina Petrova from the SciPost, May 9th of 2026. Time reading 4 minutes. Let's see, I think I'm gonna take more than that. Much more. And the second article is: scientists discover a hydraulic, link between the abdomen and the brain. Let's start with the most funny one, I think. People with similar levels of autistic traits show greater social attraction to one another, and their brains synchronize in unique ways during active conversation. I hope it works through the internet as well. That happens a lot. A recent experiment published in Biological Psychiatry suggests that social difficulties related to autism might be a problem for mismatched communication styles rather than an inherent social deficit. Yes, fantastic. It's not the lack of, it's just the uniqueness of, I think. For decades, clinical psychology has treated autism primarily as a social impairment. This view assumes that autistic individuals lack a cognitive tool called theory of mind. This concept refers to the ability to intuitively understand what others are thinking and feeling. Recently, alternative frameworks have emerged to challenge this deficit-based assumption. One major alternative is the double empathy problem. This idea proposes that social friction is a two-way street. Neurotypical people and autistic people have vastly different ways of experiencing the world and processing sensory information. These differences lead to mutual misunderstanding, meaning neurotypical individuals also struggle to read the minds of autistic people. It's always hard to read the mind of others. It's impossible, of course, no? But through face movements, gestures, sounds, movement, etc. Building on this concept, scientists developed the dialectical misattunement hypothesis. This hypothesis relies on predictive coding, a theory explaining how the brain constantly generates guesses about what will happen next. When an event matches the guess, interaction feels smooth. When a person's behavior violates those expectations, the brain experiences a prediction error, leading to social awkwardness. Following this logic, people who share similar psychological traits should predict each other's behavior more easily. An autistic person avoiding eye contact might cause a prediction error for a neurotypical person who expects a steady gaze. I don't know quite well what a neurotypical person means, and I'm a psychologist, but okay, let's continue. However, another autistic person would not find this behavior unusual. This shared wavelength should lead to more fluid interactions and a sense of mutual attraction. Lead author Xu Yuanfeng, working with Peng Sang and Xu Yunbai from Tianjin Normal University in China, designed an experiment to test these ideas. Past research evaluating how well people with differing autistic traits connect has yielded contradictory results. These researchers suspected that earlier experimental designs caused this inconsistency. Previous studies typically placed two people in a room to interact. This method makes it hard to separate a person's general friendliness from their specific chemistry with a partner. By assembling larger groups, researchers can use a mathematical approach called the social relations model. I want to research more about that. I have to remember this. Social relations model, a mathematical approach called the social relations model. This model isolates genuine interpersonal attraction from general social tendencies. The research team measured autistic traits in hundreds of university students using a standard questionnaire. The students were not clinically diagnosed with autism. Instead, they took a survey that scores general behavioral and cognitive traits associated with the autism spectrum. The team selected students scoring in the highest and lowest 10% to represent high and low autistic trait groups. The researchers then assembled isolated groups of 4 people who had never met. Each group contained 2 individuals with high autistic traits and 2 with low autistic traits. In total, the study included 20 female groups and 10 men. Am I back? I'm sorry. Our technical difficulty of the day, like every stream. So I'm assuming you're still listening to me, and the music's still there, but I can't hear it. So let's continue. The study included 20 female groups and 10 male groups. Why the double of female groups? I don't know. Let's continue. The researchers used functional near-infrared spectroscopy to monitor the participants' brain activity. Wow! This technology uses small optical sensors placed securely against the scope. It is an invasive technique? I'm not sure. The sensors use light to measure blood oxygen levels in specific brain areas. Wow! Highlighting which regions are working the hardest in real time. The participants wore these sensors caps while completing a series of social tasks. It's a non-invasive technique or tool, I think. First, the group sat quietly and listened to an audio story. This passive task allowed the researchers to measure how similarly their brains responded to the exact same information. Scientists use an analysis called intersubject correlation for this purpose. It measures the overlap in brain responses across different people experiencing the same audio stimuli. What a sophisticated research! Next, the participants engaged in a structured group discussion. They debated a classical survival scenario, deciding which imaginary characters should be rescued from a desert island. Wow! The discussion followed strict turn-taking rules to prevent people talking over each other from muddying the brain data. Following the discussion, participants privately rated how much they wanted to continue talking to or become friends with each group member. The responses revealed distinct patterns of interpersonal chemistry. Participants with similar levels of autistic traits reported a stronger desire to socialize with one another. A person with high autistic traits was drawn to the other high-scoring group member, while those with fewer traits gravitated toward each other as well. This mutual affinity only emerged second time in a row with technical difficulties. I'm very sorry. Let's continue and finish this quick before everybody gets stressed by this. This mutual affinity only emerged when their opinions aligned during the survival task. Personality similarities like extraversion did not drive the attraction. Instead, agreeing on the survival topic helped individuals with similar traits perceive a deeper shared perspective. This shared vision served as the foundation for their social attraction. The brain scans offered insight into how these connections formed on a biological level. Imagine that. The levels of oxygen in our blood, in our brain, telling us this. Wow. During this passive story listening task, pairs with low autistic traits showed similar neural responses to the audio. Pairs with high autistic traits showed more varied, unique brain responses to the same story. When communication shifted to the active group discussion, the brain activity aligned differently. The researchers measured interbrain synchronization, a phenomenon where two people's brain waves match up during a shared activity. A higher degree of synchronization indicates a smoother, more effective transfer of information between two minds. By induction or resonance, I don't know. Pairs with low autistic traits showed higher brain synchronization in the right temporoparietal junction. This brain region is heavily involved in social perception. People rely on this area to automatically process social cues and read the unstated intentions of conversational partners. Pairs with high autistic traits demonstrated a completely different neural pattern. Their brains synchronized in the right dorsolateral prefrontal cortex, very different. This area of the brain managed cognitive control, sustained focus, and deliberate problem solving. This neural pattern suggests that people with high autistic traits rely on an alternative mental strategy to process social interactions. Rather than relying on automatic social perception, they may recruit extra cognitive resources to deliberately build a connection. That's maybe why it's so hard or tiresome to interact with other people for more in the for the person that is in the autistic spectrum, I guess. This strategy allows them to successfully align their brain activity with a partner who thinks similarly. These findings challenge models portraying autism solely as an impairment of social cognition. Okay, talking from the brain region of the activity, it sounds like that as well. Instead of failing to communicate, individuals with high autistic traits seems to use different neural pathways that are fully capable of supporting social bonds. That's true. The brain imaging supports the idea that social struggles might arise from a mismatch in cognitive strategies rather than an inherent inability to connect. I agree. This study has a few limitations to consider. The neuroimaging equipment only detects blood flow near the surface of the brain. That's true. As well, deeper brain structures involved in processing social rewards remain unobserved. Also, the structured nature of the timed laboratory task might not capture the organic flow of everyday social life. The study participants were university students with varying levels of autistic traits, rather than individuals formally diagnosed with autism spectrum disorder. Wow! Very important detail. The researchers noted that future studies could apply these methods to clinical populations, using larger imaging machines could also help map deeper neural networks associated with these unique styles of communication. Yeah, maybe the iPods, these headphones from Apple, I think they can read your brain activity as well. So maybe they are already doing it. Okay, this is all for today because once again we have technical issues. I like to read with my background music and I'm not hearing it. So thank you very much for being here. I hope you enjoyed this interesting article and see you the next one. Goodbye. No outro today because technical difficulties. So simply